Well, good morning again, and thanks for joining us. With asking rents flattening and several years of guideline increases capped below the actual rate of inflation, reducing expenses is really, really valuable. Today, you'll learn about several Enbridge incentives for market rental apartment buildings and even bigger incentives if many of your residents pay lower rents. The litmus test for that is if they haven't moved for about 15 years, then they're paying below market rents, and that may mean you qualify. Our expert panel will explain how this works and provide specifics to improve your resident comfort and save you money, and the details of the upfront financial incentives for the upgrades. I'm going to first introduce you to our panel of experts. First up will be Dana McCormick. She's an energy solutions advisor delivering Enbridge's affordable housing multi-residential incentive program. She works with customers to determine their potential for improved energy performance and provides financial incentives to offset the implementation costs of energy conservation measures. Dana has 20 plus years of experience in energy management and is excited to be working as a resource for multi-residential customers. Next will be Leslie Mann. He's the Vice President of Mann Engineering. He's a professional engineer specializing in energy management and mechanical retrofits in multi-res buildings. He has successfully delivered hundreds of energy retrofit projects and help clients recover millions of dollars in incentives and grants. Mann Engineering works closely with Enbridge to ensure that building owners maximize energy savings and incentives received from projects while minimizing capital cost. The third will be Sam Van Berkel. He's a professional engineer as well and is president of Watershed Technologies. That's a firm with over 30 years of experience in water and energy conservation for multifamily rental buildings. Watershed specializes in building automation, energy analysis, and water efficiency, with typical projects saving 10 to 20% in utility costs and paying back within 1 or 2 years. They work closely with clients to reduce their operating costs and deliver long-term savings. And Frank Snyder is president of Novatherm Canada, which was established in 1995 and provides heat reflectors for reducing energy consumption and improving occupant comfort in apartment buildings with hot water heating. His reflectors are manufactured in Ontario, which is very important these days. So thank you for doing that, Frank. Before we start, we're recording this session so you or your team can watch it later or again. Please be mindful that we don't store these for very long. So if you want to watch, let us know and we will send you the link. We don't post these publicly. It's upon request only. And second, if you have any questions, there is a Q&A chat box that you type them into. And at the conclusion of the 4 presentations, we'll get to them sequentially. Okay. You also have received in via email, probably about 10 minutes ago, a copy of today's combined presentations. So if you it's the same one that we're going to display on the screen. So you have a copy to refer back to later on. So I'm going to share my screen and ask Dana to come up.
Great. Good morning. My name is Dana McCormick. Thank you very much for the introduction, Daryl. I deliver incentives primarily for our affordable housing customers, but I will also assist directing you to our various commercial team members as well if your buildings do not qualify for the affordable housing incentives. Next. So I'm just going to cover quickly today what we have on our offerings. So again, we have 2 streams for our multi-residential customers. There's what we call commercial, so that would be private market rate buildings, and then affordable housing offers, which I'll go through how to qualify your private market buildings as affordable. We offer custom incentives, fixed incentives. If you've participated in our programs before, you might have heard this referred to as prescriptive incentives, an affordable housing direct install, which you'll learn more about from Frank, energy assessments, so energy audits, building modeling, and new this year is our boiler optimization pilot, and both Wesley and Sam are approved vendors for to deliver this program. Next, please. So affordable housing, next. So we have two streams of target market that qualify for our affordable housing. So social housing providers, social and assisted housing, nonprofits, co-ops, shelters, and supportive housing auto qualify. If you do have in your portfolio, as some property managers do, a any charitable housing, that would auto qualify for our affordable housing. And then we have the private market rate buildings. This is determined by rent roll checks. So if you're interested in pursuing an energy efficiency project, we do recommend, especially if you do have a lot of tenure with your tenants, that you submit your rent rolls to us. We will then qualify the building as affordable, and we just require that a minimum of 30% of the units are at a maximum of 80% of median market rate as posted by the CMHC. Next, please. So how we do that, you can actually see this online. It's publicly available. The CMHC Housing Market Information Tool is where you would go. We go by neighborhood. So it's the median market rate as posted for the neighborhood. However, if we are missing information for your neighborhood, then we'll go up to the zone level. And how you find that is you can enter your postal code or address, and the market rate information that the CMHC has on file will appear. We will then go, if you go to full view, and then select median rent, and then you see sort of it. I'm really sorry that that table is blurry, but if you see it, it will show you 1 bedroom, 2 bedroom, bachelor, and 3 bedroom amounts, and that would be the median rent for that particular neighborhood, or if you have to go zone, that area. So what we look for is that at least 30% of the units are rented at a maximum of 80% of this rate. So if you wanted to pre-qualify just to see, or just send the rent rolls to us, we do not forward them on anywhere else. If they do not qualify, we actually delete them from our system. Next, please. Our program offers. So the majority of our multi-residential incentives will come through our custom offers. We will incentivize the implementation of various technologies, which will avoid gas usage, so reduce your gas consumption. These are our primary ones for multi-res. However, anything you're pursuing that may reduce your gas consumption, do contact us. The worst we can say is no, we can't incentivize that. So we are currently offering incentives for controls and building automation systems, heat recovery, solar thermal systems, which would be solar domestic hot water, solar walls, variable frequency drives on your ventilation systems, heat pumps, which is new in the past 2 years. And the heat pump technology would include hybrid make-up air units with a heat pump as primary heat source and gas burner or hydronic coil as the redundancy and backup, as well as tie-ins to your hydronic system with an air-to-water heat pump, air-to-air heat pump to replace radiators are also considered. Heat pump projects will always be on a project-to-project basis, as are all custom offers. So do contact us as early as possible to establish what the incentive is. And of course, heat reflector panels for buildings that don't qualify as affordable housing can be incentivized through our custom offer. Our incentive rates, and this is as you can see here, this is really why we encourage everyone to provide us the rent rolls to qualify as affordable housing. They're 10 times, our base rates are 10 times that of the commercial rate, and commercial is what we would apply to private market buildings that do not qualify as affordable housing. These are the rates that are applied to the calculated estimated savings. So we do our in-house calculations of how much gas per year in implementing the energy efficiency or energy conservation measures will result in, and then we apply 25 cents to that savings for a one-time incentive, which is delivered to you after the measure is verified as implemented. And then in affordable housing, it's $2.50 to that savings. So as you can see, that's quite a significant difference. The caps are also different. So we will pay up to 50% of incremental cost to a maximum of $100,000 on commercial, and up to 75% of the incremental cost to a maximum of $200,000 on affordable housing. It's important to note that the incremental cost is also a calculated cost and may not equal your full project cost. It is the difference between a base job, so a non-energy efficient solution, to that energy efficient solution. This could be the entire project cost when you're looking at control systems and heat recovery, or it could be from a base to a more efficient solution when we consider VFDs or new MUA, makeup air unit replacements. We do have enhanced offers, which are limited time this year. We've increased our control projects on the commercial to 50 cents per cubic meter for this year, with up to $1 if we can verify that the controls have been implemented, installed by the 31st of August 2025, and that's still up to a 50% of incremental cost. We are actually seeing that these jobs are hitting the cap, which is great, because it means people are getting a control system for 50% of the cost. Affordable housing, right now we have $3 annual, $3 per annual M-cube saved for projects that are coming in for the 30th of June and completed by the 31st of October 2025. I'm just going to highlight the 31st of October 2025, regardless whether or not you are on the enhanced offer or the standard offer. All projects must be in for the 31st of October for this year to receive 2025 incentives. If not, we will do our best to roll them over into the next year, but I have no line of sight on what our incentive amounts will be for that. Affordable housing is up to 75% of incremental cost to a maximum of $200,000. At this point in time, I would waive that 30th of June deadline for applications with the intent, and offer $3 a cubic meter for projects that are going to finish this year. Next, please. The other thing that I think a lot of people miss is that many of these measures also result in electricity savings, and the IESO also has a program. It's the Save on Energy program. I know that both Wesley and Sam have experience helping their customers with the applications on the Save on Energy end of this. VFDs controls will generally have anything that you're scheduling, in other words, will generally have electricity savings as well. And our incentives are stackable. So you could end up with the majority of your project covered by incentives. So definitely worth pursuing. Our direct install is available to our affordable housing customers, which would include private market customers who qualify. And this is a completely gratis program. So it's free installation for heat reflector panels. And this is completely the project management, the installation, and the delivery of the program is all done through Novatherm. It's sort of a no stress solution for our affordable housing customers. We do have some requirements for eligibility. We do need customers to commit to installing panels in at least 90% of the units. We'd like to see 100, of course. And we will ask that the boiler supply temperature is reduced by 10 degrees Fahrenheit after implementation, as that is part of it. They go in, they clean the radiators or convection unit or convectors, sorry, and install the heat reflector panel behind. I've seen the installations, they're very clean. I'm really happy to report that I get very good feedback from tenants with respect to their installation crew. So it's an excellent solution, a no-cost solution. We also offer prescriptive incentives, and to be honest, I do not have a lot of these coming through. Most ERVs and HRVs, I actually qualify through the custom program. Condensing makeup air this year has actually an increased incentive, as does hybrid rooftop units. I just want to spend 1 second on that. So the hybrid rooftop units are only the prescriptive is only applied to mixed air units and only up to a certain tonnage with respect to the heat pump size. Most multi-res units have makeup air, which will come into our custom program. We offer the same prescriptive incentives in affordable housing, but as you can see, the amounts are quite a bit different again. This is new this year. It is our boiler optimization pilot. I'm just going to read from the slide, forgive me, because it really says everything I want to say. So boilers can get a long-lasting efficiency boost when the building's entire heating system is holistically assessed and performing optimally. So our approved delivery agents on this will go in and they will assess your heating system. So perform a series of audits and assessments, see where there are improvements to be made to increase your overall efficiency, including balances, the configuration of your boiler loop. They'll look at your control system and see what can be optimized there. And this will enable you to reduce your gas consumption. There are requirements. However, if you feel that you could benefit from this, but you're not quite making that 250,000 M cubes in consumption, still give us a call. It's worth the discussion. We'd like to increase our participation in this program. And next, please. Just there's another slide. So it covers the initial assessment up to $10,000 per site and up to 50% of the audit costs. They will come up with a list of solutions and suggestions to improve your efficiency. If you implement these recommendations, we will give you $1 a cubic meter, or for our affordable housing customers, again, it's always going to be deeper. So that's $2.50 a cubic meter for affordable housing, up to 75% of the upgrade costs. And that's for both. So you're no longer stuck with the 50%. It's up to 75% of the upgrade cost and up to a maximum of $100,000. And then we will also give another $10,000 in top-up assessment incentives if any of the recommended optimization measures are implemented. You can see here. Oh, sorry, Daryl. I was just going to hit on the 31st of August, and the implement and submit by November 30th. We are stretching that date as long as the project can be completed by the 30th of November. We will work our best to qualify you because we know that 31st of August is pretty tight at this point. We also offer building energy assessments. There are offers for audits on the commercial rate as well. They are dependent on how much you consume. However, again, our affordable housing customers benefit the most off of this program. I will, or myself or our other affordable housing ESAs will approve up to $8,000 per building to cover up to 100% of the audit costs, not including the HST. We do have an annual limit of $40,000 per housing provider. And pre-approval is required. So you will need to contact us before we approve it, or the consultant or contractor delivering the energy audit can also give us a call on your behalf, but they do need to be pre-approved. We are very limited in funding for this right now. It is the one measure that we are given a very set and tight budget. So if you're interested in this, please contact me as soon as possible so we can reserve the funding. I do have just a couple of implementation stories to tell. So this is just a control job where they implemented a BAS system. The boilers had been running off of their limits. And they also included the makeup air units. They received $35,000, saved 14,195 cubic meters per year, which is perpetual savings beyond just the incentive, which I think is the biggest benefit of any of these projects, are that you're saving continuously year after year. And they also reduced their carbon footprint, which is something we're all striving to do as well. Heat recovery on a makeup system. This was a very large savings. You can see that it was 31,925 cubic meters a year. They received $80,000 for it and reduced their overall carbon footprint by 62 tons, which is fabulous. This is, I think this is often sort of dismissed as a viable measure that has a big impact. But as you can see, they added VFDs to 3 gas-fired makeup air units. The savings were quite substantial. Project cost was only $24,000 for the 3 units. They exercised applying for all incentives possible, so Enbridge and IESO, and they 74% of the total project was covered. You can see there was a significant reduction in CO2. There's very low disruption to the tenants, which is always important. The work is all done on the rooftop, and it was just an overall win for the customer. It's very easy to get started with our application process. We do everything in-house, including filling in the application. We do all your calculations and incentive the incentive determine the incentives for you. So it is a very low stress process. It just starts with a phone call or an email, and my contact is there. Um, I know Daryl will make sure everyone has these contact information. If you call me or email me, I'll make sure, even if I can't deliver your incentive to you, that it is directed to the person who will help you.
All right.
That's it for
Thanks.
me. Thank you.
Thanks, Dana. Everyone does have this presentation and your contact information. Just to reiterate, when Dana and Enbridge say commercial, they mean market rental. And when they say call something affordable, you can kind of self-assess on a back of an envelope, look at your rent roll, use the CMHC website to determine what the average median rents are in your neighborhood. And if 30% of your units on a unit by unit basis are paying 80% or less of that number, then you qualify for the incentives that are seemingly 10 times higher. If you need any help with that, call Dana or even call us and we can help you through the process if you're uncomfortable with giving Enbridge your data right away. So self-determine. I think if 20%, if a lot of your tenants haven't moved in the last 15 or 20 years, then you probably qualify. Many of the GTA members will qualify. Next up, thank you, Dana, is Wesley. Go ahead.
Hi. Yeah, thanks for the introduction, Daryl, and Dana. Thanks so much for briefing everyone on the Enbridge incentives. So I'm Wesley. I'm from Mann Engineering, and I'm a professional engineer. And my primary role is a consultant, mechanical, HVAC, and electrical consultant for my clients. And I help work with Enbridge, and my team works with Enbridge to maximize incentives on projects and help deliver a successful project. So let me move on. Just introduction. So Mann's actually been around for a while. I'm actually second generation, if you haven't guessed. So we specialize in energy management. So we're experts at saving our clients money on their utility bills and reducing their long-term energy costs and reducing capex on projects. So that's our specialty. First step is usually an energy audit, and we work all the way through the full scope of the project. So engineering, we also offer design, build, and project management solutions, and of course, incentive administration as well. So next, Daryl. So just doing a quick highlights on what I'm going to be covering today, some of the different offerings that we can help out with. First, like I mentioned, is energy audits. So this is usually step one when we're evaluating a building to help determine what types of projects make sense from a financial feasibility perspective. So we'd be looking at different energy conservation measures that we think are a good fit for the building, because we evaluate every building on a building by building basis. Every building's different. The mechanical systems are different. Not every solution is going to work for every building. You know, there may have to be a custom solution depending on the actual characteristics and the layout of the building. So we identify custom measures that we think are good candidates for energy savings, and we evaluate each of those measures based on project costs. So we'll do a full budget estimate for the capex, and then we'll also look at any incentives that may be available, because that will obviously offset the capital cost and reduce the net capex for the project. And then another thing, obviously, is energy savings. So these are long-term savings, year by year, which eventually will produce a payback. So we are going to evaluate what the life cycle costs of the project is, and what the return on investment would be for the project when taking into consideration multiple factors like energy savings and maintenance upgrades. I'll go back one more slide. I just want to quickly go through the other things I'm going to be covering. Ventilation system retrofits, your makeup airs and exhaust fans. And typically this would also, the third thing I'm going to cover is heat recovery systems, which would generally be done in conjunction with ventilation system upgrades. I'll also be quickly talking about variable frequency drives and what applications make the most sense for them. And then finally, the boiler optimization pilot. So I can go on to the next one now. So I did discuss this a little bit on the previous slide, but first step is always an energy audit. These are the things we'll look into, and it helps assist the building owners and management make informed decisions about what types of projects make the most sense financially. So as far as ventilation system retrofits, we've been doing a lot of ventilation system retrofits this year. Previously, as most people know at this point, as of 2025, there's no more direct incentives from Enbridge for boiler retrofits. So a lot of the funding has been going towards ventilation systems and controls. So makeup airs, it's a great time to upgrade your makeup air systems and exhaust fan systems and potentially add heat recovery, because the incentives have been really good on the custom incentive stream, especially if it's affordable housing, as Dana mentioned. So the first type of system I want to go over is hybrid heat pumps. Now, this is a new incentive from Enbridge. So how a hybrid heat pump works is it's pretty much operates like a standard air source heat pump, where it's extracting heat from the atmosphere or rejecting heat into the atmosphere. One of the main benefits is it actually can do heating and cooling. So if you do have a makeup air that has cooling, this is a good option as a retrofit, because the heat pump will do both, and it provides year-round heating or cooling. And it could be a good option too if you're looking to add cooling to your corridors as an additional measure for your building. The only downside to the air source heat pump is cold weather operation. The efficiency drops quite a bit. So typically you'll need a backup heat source. This could be a gas burner. Electric resistance heater is not ideal, but that's an option too. Hydronic coil is a good option. Condensing makeup airs. It's your typical gas-fired unit. So this could be a simple re-and-re, where you could use your existing gas line going to the units, and pretty much everything would just be a re-and-re. The only difference being it's a condensing unit, so it extracts a lot more efficiency out of the combustion. So you end up with efficiency, in excess of 90%, whereas a typical gas-fired unit would be more like 80%. The main issue with this condensing makeup air is the condensate. So because the units are typically located on the roof or outdoors, the condensate will freeze. So this is the main complication we have to address when doing condensing makeup airs, is figuring out a way to prevent it from freezing and potentially causing the unit to not run. One of the ways we do that is with a heat trace system, or if the unit is actually indoors in a penthouse or in somewhere else, or potentially we can look at relocating it indoors, then this isn't so much of an issue. Yeah, next slide. Okay, so glycol coils. This is something we can really help out with. We do a lot of these projects because it's actually a long-term great solution for the makeup air, because what you're doing is you're eliminating the gas-fired burner, which is another gas appliance you have to maintain, and typically they have pretty low efficiency. And you can actually heat the makeup air directly from your existing boiler plant. So this works well if you have a penthouse mechanical room. We can pipe in a heat exchanger to provide a glycol loop. It has to be glycol because, again, it's outdoors, and makeup air systems, the air is very cold. You can't have water going through it. It'll freeze. So it's a glycol coil, so it means you need a heat exchanger. There's a bit of piping and engineering involved, but depending on the layout of your roof, it could actually be a fairly cost-effective solution where you don't actually need to replace the whole makeup air. It can be refurbished and a retrofit with a hydronic coil, and you can add a VFD, which is great. So these types of projects can actually, we've seen very good custom incentives, up to 75% we've been reaching with our affordable housing clients. So this is a great option. Next slide. Yeah. Okay. So, but yeah, like I mentioned, sorry, can you go back to VFDs there? Yeah, perfect. If you're going with a glycol coil retrofit, great time to add a variable frequency drive to the unit. Now, when you're adding a variable frequency drive to a gas-fired unit, there's a lot of complications. If it's a single-stage gas-fired unit, typically you can't modulate the fan speed. You might have to retrofit the burner for a modulating or two-stage burner, because at a fixed, like single-stage gas-fired unit, if you reduce the fan speed too much, that coil is going to get hot spots and destroy itself. So you typically can't do that. But if you're going with a hydronic, like a glycol coil system, no issue. You can modulate the fan speed. And not only does the VFD provide electrical savings on the fan, but more importantly, by limiting the amount of unconditioned air you're bringing into the building, that greatly reduces the heating or cooling costs of that system, just by limiting the amount of, you think about in the middle of the winter, if you're bringing in 100% fan speed of -20 degree air into the building, all that cold air has to be heated, which is cost. So if you can reduce the amount of air you're bringing in, fresh air that you're bringing into the building, that greatly reduces the cost of heating or cooling. Next heat recovery option we'll talk about is the enthalpy wheel. So this is like they call it a desiccant wheel, or it's basically it recovers both heat and moisture. So we call that latent heat. So it has very good energy recovery, like 60 to 80%. One of the main downsides of this is it's very dependent on the system layout. If you have a central makeup air and exhaust fan right next to each other on the roof, perfect. It could be a great candidate. If you have a roof where you have maybe multiple exhaust fans, or your systems are pretty spread out on the roof, or you have individual suite exhausts, this isn't really going to be an option. It kind of requires the exhaust duct and fresh air duct to be very close to each other. So it may not be a good option, or may not be possible in many buildings, but where it is possible, it could be a great option. Glycol runaround loop. This is an option for heat recovery where, I mentioned in the previous case, if you have equipment that's kind of spread out all over the roof, you don't have a central exhaust and central makeup air right next to each other. This could be an option. This is essentially using a glycol coil. So we have piping running around the roof, connecting each unit together with a coil that we would retrofit into the existing units or new units. So this would allow the exhaust air to transfer heat into this runaround coil, and that heat would be transferred into the fresh air coming in the makeup airs. So it's just a way of moving heat around across multiple units. The main downside is the efficiency is not going to be as good. It's pretty low grade heat, so you're looking at less than 50% heat recovery typically, but and the cost of actually running around the roof with piping could be potentially high. So those are kind of some of the main downsides there. Exhaust air heat pump. This is in ways similar to the glycol runaround loop. It allows you to connect potentially multiple units that are separated by a distance. But the main thing is it's using a heat pump. So instead of just relying on the glycol as a medium of heat transfer, you're actually using a refrigeration cycle to pump heat from that exhaust air into the fresh air. It can be very, very efficient. So like you can get COPs of 4 or higher. Basically, that means like 400% efficiency, and that is possible with heat pumps because it's not actually generating heat; it's just moving heat. So it's very, very efficient. So you can get great heat recovery. The main downside is obviously cost, and it's another piece of equipment you have to maintain. It's another heat pump that you have to maintain, and it relies on having the sufficient electrical capacity. Same goes with any heat pump retrofit. You always have to look at, is there enough electrical capacity on the roof or wherever you're installing it to support that heat pump? Because if we have to do any electrical upgrades, that adds significant cost. Another option for ventilation retrofits is going to individual suite HRVs or ERVs. So this is kind of decentralizing the ventilation system. If you have in-suite exhaust fans already, then you're kind of halfway there. You can install in-suite ERVs to provide fresh air directly to the suites. And then the makeup air unit itself could be potentially eliminated, but more likely just greatly downsized so that it only has to serve the corridors, and it's not having to serve all the suites as well. Because the main purpose of the makeup air is, one, to provide ventilation, fresh air, and two, to make up the air that's lost through the exhaust systems in the building. So by putting the in-suite heat recoveries, it allows the suites to be like the occupancy to be kind of controlled based on a suite by suite basis. So it can be very, very efficient. But obviously it's quite a big retrofit and involves in-suite work. So potentially the cost of the project could be fairly high. So now variable frequency drives. I want to go over some of the best applications for variable frequency drives, because there are certain applications that make more sense than other applications. Now, as far as energy efficiency, so obviously there's electrical savings. Now, the energy consumption of a fan or a motor that controls a fan or a pump actually scales with the cube of the fan speed. So you get a much more savings than you think you might be able to get just by reducing the fan speed. But also the main savings comes from the downstream systems that VFD is controlling. So like I said, with the example of the makeup air, not only are you saving on the fan speed, but on the electrical consumption of the fan itself, but you're also saving heating costs, right? So ventilation is a great application for VFDs, because we can put the fan on an occupancy schedule. And now that's typically done through the BAS, so you'd want to have an integrated control solution here. But basically, the building's not fully occupied all the time. People go to work during the day. At night, they're sleeping, so the ventilation requirements are lower. So, overnight, typically we would drop the fan speed down to 50%, and you'd have a different occupancy schedule with different speeds throughout the day, depending on the profile of the building. So it can be a very energy efficient solution there. Now, and garage exhausts is another example where if you have a CO system for your garage exhaust fan, if the garage is heated too, that can provide additional savings. Now you can modulate the fan speed of the garage exhaust system to match the actual requirements based on the CO. Booster pumps, another great example. That's a pumping system that's running 24/7, 365. So any reduction in speed there will provide great savings in the long run. Cooling tower fans and condenser pumps. Again, not only does this have savings on the fan and the pumps themselves, but it can actually optimize the efficiency of the chiller. So you're getting kind of compounding savings there. And heating and domestic hot water pumps, a similar example to the chillers, where not only are you saving on the pumps itself, but also you can optimize your boiler system. So the boiler optimization pilot, this is a brand new program that's new for this year, and it's kind of on a first come first serve basis. And we are one of the approved assessment partners that you can work with on this project. So the idea behind this project is, and I've actually been talking to Enbridge for a while about having something like this, is because we notice out in the field all the time that because of the prior incentives that were primarily focused on boiler retrofits and wanting to get condensing boilers into buildings, lots of condensing boilers were retrofitted into existing systems where they're not actually getting condensing efficiency. So one important thing to know about condensing boilers that I like to tell all my clients is that the nameplate efficiency is only achieved at certain operating conditions, meaning that you actually need to have very low water temperature going into the boiler. Now, the thing about most existing buildings, they were designed around non-condensing boilers, which require the water temperature going into the boiler above 130 degrees. So when you're retrofitting a condensing boiler into a boiler system that was designed to work with non-condensing boilers, it will never condense, and you will basically get the same efficiency as you would get with a non-condensing boiler. You actually have to change how you operate the boiler system, and potentially you have to do design changes to the building or the mechanical system itself in order to actually achieve the efficiencies that you think you're going to get. So I've seen lots of cases where condensing boilers have been installed where they're not getting any additional savings, but they've spent a lot of money on the new condensing boilers, and it also comes with higher maintenance costs too. So this program is really designed to look at those systems that where there's potential for savings just through optimization of the boiler system. So the main goal here, like I said, is to reduce the water temperature that's going into the boilers so that we can actually get to condensing efficiency. Just a quick background on how condensing boilers actually work is, non-condensing boilers, for instance, the flue gases going out into the atmosphere are fairly hot. So that all that heat is basically wasted because it's going out into the atmosphere. What a condensing boiler does is it extracts as much heat out of that combustion cycle as possible by actually condensing the flue gases. So the actual vent gases going out into the atmosphere are a much, much lower temperature, which means all that heat is actually going into the building instead of being wasted into the atmosphere. But the only way you can do that is if the water going into the boiler is cold enough to actually extract enough heat out of that system. So typically we want the water temperature to be less than 130, and the lower it is, like 90 degrees, I'm talking in Fahrenheit, or lower, you're going to get much closer to that 95 plus efficiency. So that's the goal here. Now, different measures we may recommend to do this is, one is just BAS optimizations. A lot can be done in software, outdoor reset curves, and just optimizing the water temperatures in the system to try and improve the efficiency. And another big thing is on heating systems. A lot of these buildings were designed to operate at 180-degree design temperature. So the RADs and all the terminal units, they may require very hot water, 180 degrees on design days, in order to actually provide enough heat. So one of the things we may look at is replacing RADs with low temp RADs, different heat exchanger or coil replacements on air handling units that are designed to operate at a lower temperature. And by doing that, that allows us to bring that heating curve down in the BAS and provide much greater boiler efficiency. And testing, adjusting, balancing. So TAB, it's something that's very much overlooked in a lot of buildings. But to give an example, I've seen lots of buildings where there may be a few suites in the building, or maybe one riser that is consistently always much colder than the rest of the building. And so they call the BAS guy and say, hey, we need the boiler plant temperatures increased. So they'll go ahead, and the whole heating curve will be adjusted to provide that to provide enough heat to that one suite or that one riser. Whereas if you could just adjust the balancing in the building so that the building's heated more consistently, then all of a sudden you can bring your boiler temperature, your outdoor temperature curve down, because you're no longer having to worry about maintaining that one riser that doesn't get enough heat anyways. Well, meanwhile, you're cooking the rest of the building. So a lot can be achieved just through rebalancing of the systems. And then, like I mentioned too, a lot of these buildings were designed around non-condensing boilers. So in a lot of cases, they're not meant to work at low temperatures. So there's potentially some mechanical retrofits that have to happen, piping modifications or changes to pump design, in order to make sure that the boiler system can work at low temperatures and optimize performance for the condensing boilers. So potentially, those could be implementation measures that could be covered by the incentive program. But it's important to note that this incentive program specifically does not cover replacements of boilers. We're only looking at optimizing an existing boiler system. And if you have any questions about anything I discussed, you can feel free to contact me or Enbridge, and we can get going. So thank you.
Thank you, Wes. That was very detailed. Yeah, awesome. We're going to get to some questions at the end. So next up is Sam from Watershed. Sam, please. There's Sam. Sam, you have to unmute yourself.
Sorry about that.
There you go.
Yeah, I'm Sam Van Berkel, the president of Watershed Technologies. So go ahead, Daryl, next slide. Yeah, so Watershed was founded in 1977. Obviously, I wasn't around then, but I've been involved with Watershed for over 10 years now. We really specialize in multifamily rental apartment buildings. We have three main business areas. The one I'm going to focus on today, of course, is building automation and heating controls. But we also do engineering design and analysis, and we have an efficiency program to reduce water consumption in apartment buildings as well. We work with some major clients. So one of our main focuses in building automation is addressing overheating in apartment buildings. So as many of your members will know, the older multifamily buildings often have this issue where they're overheated, particularly in spring and fall. And this happens because a lot of these buildings don't have adequate in-suite controls. So some of them were built without any thermostats in the units, and some of them were built with thermostats, but often those thermostats over the years have been decommissioned. They're no longer functioning. So when there's too much heat delivered to the building, those units overheat, people open their windows, and your energy bills go up, and your money literally goes out the window. So at Watershed, we're really keen on monitoring energy usage on an hourly basis. So here's an example where you can see hourly gas consumption plotted from a typical building from September 15th to October 15th. So you can see when we turn on the space heating system October 1st, we see that gas consumption more than double. And this is a classic sign of overheating because the heating load when we've gone from, September 29th to October 2nd, for example, is not increased by double, right? The outdoor temperatures haven't gone down that much, but we see this huge overhead in gas consumption. So that's really costing you a lot and is really what's resulting in that overheating. So to address this issue of overheating in this particular building segment, we developed a process called interval data optimization, or IDO. So this is based on 10 plus research into energy use in rental housing. And it works by evaluating the real-time energy use of the building and then delivering only the necessary heat instead of overheating the building. It allows for lower temperature operation of the boiler plant in those shoulder seasons. And a CMHC has done a case study and found 33% space heating savings for a sample of buildings. This is just a quick little infographic of illustrating the concept. So basically, your boiler plant at the bottom there is operating at a higher temperature, and then we're circulating a lower temperature through the building. That's reducing that overheating, preventing residents from feeling like they need to open the windows. And then, of course, that's reducing your energy bills and improving comfort at the same time. So how does this work? So the gray points here are typical, each point represents a day of gas consumption. And on the x-axis, you have the outdoor temperature. So as you'd expect, gas consumption increases as it gets colder outside, but you really see this huge disconnect between when you're only heating domestic hot water in the summer and when you start heating space heating. There's this huge jump in energy use. And we call that the overhead. So when we see that, we know that this building is overheated. And then what we do is we basically plot a line from the balance temperature of the building, which is for these buildings is typically 15, 16 degrees Celsius. And then we plot that line up to the coldest point. So we're not expecting the building to use less energy during the coldest part of the year when it's minus 15, minus 20 outside. But we know that we can reduce the gas consumption in the shoulder seasons or all that period in between when it's when the temperatures are every hour. And that feeds into our server, our central database called Energy Brain, which also pulls in environmental data about the temperature in the area, the sun conditions, wind data. So if you have, for example, a south zone, we can reduce the temperatures a little bit when it's sunny. And then our server processes that data, optimizes the set point, sends it to the on-site building automation system, which then adjusts the boiler output accordingly. These are just some pictures of what a typical building automation system installation looks like. So we've got the building automation system panel, clean and organized. You have access to your system online, so you can log in, you can see what the boilers are doing in real time. It also sends you email alerts if there's a system failure. So if you suddenly have no domestic hot water, you can action that before your residents start calling. And then as part of a building automation system, we're often installing variable speed drives on pumps or on makeup air units as well. And we like to put a color touchscreen display panel in the boiler room so that when your boiler techs go, they can access the system as well. So just to highlight one recent project that we did for a building on Eva Road, this was done last year. So before the project, the building had mid-efficiency heating boilers, which are quite typical for the space heating system. Atmospheric domestic hot water boilers, and a Tecmar control, which is a sort of limited control that does some outdoor reset, but can't be accessed remotely and really can't be adjusted that easily. So this project, we installed the building automation system, variable speed drives for the pumps. We also, because the boilers are non-condensing and we want to operate them at lower temperatures, as Wesley was saying, Non-condensing boilers are not designed to operate below, 135 degrees Fahrenheit, so we have to retrofit a mixing valve onto the boiler to allow that to happen. And then we optimize the heating output of that system over time. So this project costs about $50,000 plus HST. Enbridge provided an incentive of $43,610. This building was an example of a building that qualified as affordable housing. So the cap was higher than the typical 50%. And then the IESO also provided some funding for the variable speed drives. So the net cost to the customer with including HST was $13,500. And as part of this project, we are connected to the gas meter so we can report monthly what are the actual gas and electricity savings. So this chart shows the gas savings over the first 7 months, and the customer saved $39,000 over the first $7 months, which works out to about 21% of the heating component of their gas use. And just in the first 3 months, they recovered that initial investment of $13,000. So a very profitable project. This is another project we did in 2016. I wanted to show an example of an older project just to kind of illustrate the savings, the longevity of the savings. So this was a really old boiler plant with original fire tube boilers. So part of what we did was recommission the zone valves for the building as well, new actuators. And this is that kind of an example of that initial plot I showed before, where you have that big overhead initially around the balance temperature. And then after the retrofit, we see that there's a more gradual transition from summer conditions where you're heating just domestic hot water. And when you turn on your space heating, you now have a smooth transition instead of that big jump in gas consumption. Now, this project over that period saved quite a bit of money, over 120,000. And I think that chart's only showing the first 3 years actually, but it's still ongoing and has saved about $35,000 a year for the customer. This is just a quick plug that we did for CMHC. So they did a paper on the IDO technology that we use. So you can find that online. It kind of walks through in more detail how it works. And if you want to learn more, there's a video we put together which talks about the building automation and IDO technology. You can also contact myself or our Director of Business Development, John. And I wanted to also mention that although our focus has traditionally been the older multifamily buildings where we have this in-suite overheating, we're also doing a lot of systems for newer buildings and seeing really good savings on makeup air units, as Wesley was talking about, implementing scheduling for the makeup air units, adjusting booster pumps. So we've really developed expertise in a whole range of multifamily buildings.
Thank you very much, Sam. That was great. And next and last up will be Frank.
Thanks, Daryl. Recognize we're running a bit on time here. My business internet was down for a while, and I think my presentation got mixed up a bit, but we'll go ahead with this one anyway. Simple, effective technology. We don't have bells and whistles. The technology, once you install this, you can forget about it because it automatically works. It's passive. We're looking for the buildings, target buildings that are heated with hot water systems. And the hot water the heat is delivered to the apartment either by convectors or radiators. Now, there has been confusion on this you might note in the Enbridge slide was radiators. And I recognize most of your buildings have convectors rather than rads, and it works on convectors as well. On this one, you can see the reflector installed in the left-hand top corner. There is a reflector behind that rad. And you can see the reflector in the bottom right-hand corner. So rads come in a variety of sizes. The convectors now, the next slide, come in a variety of sizes too. The concept works the same. You've got a heating unit, poorly insulated exterior wall. You've got a disproportionate heat loss. So we put more heat gain into the room, and is evidenced by the affordable housing with Enbridge and the commercial. Once the reflectors are in, you turn down your boiler 10 degrees. Some can do more than that. The next slide shows you the variety of convectors that we have in various types of buildings, and I've matched them up with the buildings they were in. And you can continue through. That's a rectangle type of convector, and mostly in living rooms and some high rises on the right-hand top. You get what we call the front-off baseboard in others. This is a cabinet type of convector. Same thing, it either comes out of the wall or it's inset. And you can see how we install on those. This is not applicable for fan coils or for forced air furnace. So we're looking for hydronic heating with hot water boilers. Next slide. So, and let's go to the next slide. Now, I don't have a case study in here, so we're going to pause for a second. The Enbridge incentives are based on a 10% savings of heating load. So that's prescriptive. There's no type of documentation you need on that. And the types of projects we get involved in varies. It's very building specific. 51 apartment, 3 floors might run 14, 18,000. Whereas you get 175 apartments, 11 floors, it might run 30 to 40,000. Or less than that, could be around the 20 to 25,000 range. The important opportunity now is the affordable housing, because 100% of the project is covered by Enbridge. And if we can go to the next slide. As you read the types of things they're looking for to qualify a particular building, the big opportunity you have is right now you have all of this information that Enbridge requires for your rent roll in your impact reports that you fill out. And so if you use that information and send it to Enbridge, and you go into the next slide, 100% is covered by Enbridge. There's no billing or reimbursement. Enbridge is our client. You complete the applications for them, and the rest of it we schedule, of course, according to your convenience. But there's not a lot of paperwork involved in this other than signing forms and documenting that it has been, that we do the documentation, you review it and sign it. Now, a good example of this, because some people don't think it through, if your building has 100 units, then if you have 10 tenants in that building that have been there for, let's say, 15 years, and you have another 20 tenants that have been there for 10 years, it's likely you will qualify for this program in market rent buildings. So it is really a fantastic opportunity that you should look at and take seriously. We often find people will send us, they've got 8 to 10 buildings, will send their whole portfolio impact information on the Enbridge form into Enbridge. They'll come back and say 8 of these qualify for affordable housing, 2 of them don't. So you still have an opportunity at those other 2 to have the incentive on the market rate or Enbridge commercial incentives. So it's a very good program to look at and shouldn't take a lot of time for you to investigate it. And if we just go through that now, I think we can go to the next line and go to the next slide. Darryl, if you go, yeah. So how you get started on this, first you want to identify, do you have a boiler? And is the heat delivered by convectors or rads? You can reach out to Dana, you can reach out to Eduardo at Enbridge, myself or David, and we'll help you guide through the process. The rent roll review goes to Enbridge, doesn't come to Novatherm. And once they qualify, then we can pick up from there and move forward. That I think covers it. I'll pass it back to you, Darryl.
Yeah, thanks, Frank. Thank you, everyone. That concludes the presentation part of this webinar. I just want to recap while the other speakers come back on screen. You know, Dana provided you a really good detailed presentation regarding the types of incentives that Enbridge offers. And just to reiterate what she said and what Frank just mentioned, you know, you can sort of self-analyze on the back of an envelope, per se, whether or not your building is, as Enbridge defines, as affordable. So every year you submit your rent roll door by door to MPAC as a requirement. Take that same rent roll, use the link that Dana provided to the CMHC website, type in the address of your building, right? And you'll see some numbers when you click the median rents, and you'll see numbers for bachelors, 1s, 2s, and 3s, and then multiply those, right? So if you've got 30% of your units on a unit by unit basis that are 80% or lower than the numbers on CMHC's website, you're technically defined as affordable. If you get close to that or above that, you know, then think about submitting that data to Enbridge for them to formally assess and qualify your building as affordable. And if it does, then what Frank's offering you is 100% free, and what Sam and Wesley are offering you come at different levels of a discount. So even if the building is not defined as affordable, it's just a pure market rental, the incentives are really good. But if you cross that threshold and your rents are really low, then you're gonna get almost 10 times more, or in some cases, free stuff. You know, what Wesley said was the buildings were designed a certain way with certain pieces of equipment, such as non-condensing boilers. You can't just plug in a condensing boiler now and expect it to be efficient because it wasn't designed like that. Sam basically overviewed, you know, look at the data, use the data. Computers are really smart, evaluate it and use the computers to sort things out according to people's schedules and occupancy. And Frank gave you the whole rundown on how easy it is and how you basically are reflecting the heat back into the unit with simple things. And again, if the building has a lot of long-standing tenants, then it's probably completely free. You don't even send Frank a check. Enbridge sends it to them. They take care of it. They just sort it all out for you. I'm going to now look at some questions. If you have any questions, please type them into the Q&A section and we'll answer them. The first one is, what is the best AC units on the market for portable AC for in-suite? I don't know if any of you are experts on these things, but whoever wants to take a shot at that, please just speak up.
Yeah, I can't speak too much about the portable AC market. There's lots on the market. But you know, we do a lot of heat pump retrofits for certain buildings. I would say the best candidates, best building candidates for this type of retrofit would be electrically heated buildings. They already have in-suite electrical capacity because that's, like I mentioned, one of the biggest factors is there enough electricity available? Electrically heated buildings, we know they do. If you can retrofit mini split heat pumps into the suite on a suite by suite basis, so each suite would have its own air source heat pump. And as far as electrical savings, the air source heat pump uses about a quarter of the power if it has a COP of 4 compared to electric baseboard heating. So you'd be saving a lot of cost on electric heating. And the bonus is you get cooling as a side product. So you also get cooling with the same system.
Yeah, no, that's confirmed. You know, there's been, I think, 3 buildings in the local area that have converted or installed unit by unit balcony located air source heat pumps. They're expensive. It's complicated, especially if there's asbestos in the ceilings. And but they do offer cooling as a side product. And like what Wesley said, you can only really do this in a building that currently has the electrical feed because it's being heated by electricity. Well, the one caveat is when you install these heat pumps, the cold air heat pumps still are only guaranteed to minus 25 centigrade. And it gets a little colder than that 3 or 4 days a year in Toronto. So you have to maintain and keep your legacy system in play just in case. So
that's a good point. Yes,
we can't just rip it out and decommission.
Yeah,
so
we normally keep the baseboard as a backup. Yeah.
Yeah, and so it's got to be tested and maintained just in case, right? So it's not all of a sudden, you know, rip out the old stuff and forget about it. We don't know if that's the long-term solution. It is the current, you know, shiny thing that everyone keeps talking about, but we're getting there. Next question is, what is the best garage exhaust fans on the market for underground garages? I don't know if we talked about underground garages, but
I
again,
briefly talked about underground garages. So again, there's many options on the market. But the importance I stress is that if you don't have a CO system, you should definitely get a CO system, because otherwise the fans based on current bylaws, they have to actually operate 24/7. So get a CO system if you don't have one, for sure, because that allows you to turn off the fans based on the CO levels in the garage. If the garage is heated, that will also save heating costs for the garage as well, of course.
I think those are the only questions I see. Any other questions? You have a couple minutes. I know we went over time. I apologize for that, but the speakers were giving providing such valuable information. I don't want to shorten any of the presentations. All right. Well, I don't see any more questions. So I just want to thank all of the speakers, Dana, Wesley, Sam, and Frank, for participating and providing the detailed overviews. All of the attendees for attending. You have their presentations with their contact information. Lots more in the presentations that they didn't have time to speak about. But by all means, contact every one of them. And more so, if you have any specific questions, just reach out to Dana and her team at Enbridge and give them an overview, and they'll point you in the right direction. Or call Cornelia or I at the GTAA, and we'll sort it out for you. Once again, thanks everyone for speaking. Thank you everyone for attending. We hope you enjoyed it. Have a great day. Bye for now.
Thanks, Daryl.